Have you ever just looked around and wondered how scientists make sense of, well, everything? Your desk, the air, the phone in your hand, it's all matter. It sounds complicated, but there's a really simple system for organizing it all, and we're going to break it down using something you probably see every single day. Take a look at this. A simple glass of ice water. Seems pretty basic, doesn't it? But this humble glass is actually the perfect little laboratory for our investigation today. So what is really going on in there? I promise, by the end of this, you are never going to look at a glass of water the same way again. That's right. Our lab for today is this glass of water. It's perfect because it shows us the two fundamental ways scientists classify all the stuff in the universe. First, by its physical state, and second, by what it's actually made of. So let's kick things off by looking at its state. So, how does matter actually exist in the world? We call these different forms its states. And, believe it or not, our glass of water is already showing us three of them at once. It really all comes down to two key things: shape and volume. Okay, let's break it down. First, you've got the ice cube. That's your solid state. It holds its own shape, has its own volume. Simple enough. Then, as it melts, you get liquid water. Now, it still has a definite volume, but it takes the shape of whatever container it's in this case the glass. And finally, you have gas, the water vapor that's invisibly rising off the surface. It has no definite shape or volume, it'll just expand to fill up any space it can. Solid, liquid, gas. Seems like we've covered our bases, right? I mean, that's pretty much everything we deal with day to day. But what if you take a gas and just crank the energy way, way up? Well, you get something totally different, something that's actually the most common state of matter in the entire universe. And that would be plasma. You can think of it like a supercharged electrified gas, where the atoms themselves have been broken apart. Now, you're not going to find plasma in your kitchen, but you see it in the most powerful places imaginable. It's what powers our sun and all the stars, and it's that flash of lightning you see in a thunderstorm. All right, so we've covered the how, the state that matter exists in. Now let's switch gears and talk about the what. What is this stuff actually made of? And for that, you guessed it, we're going right back to our trusty glass of water to look at its chemical makeup. So the most basic building block of everything is called an element. Think of it like a fundamental ingredient that you can't break down any further. It's a pure substance made of only one type of atom. Oxygen is a great example. It's just made of oxygen atoms, and that's it. Okay, so what happens when you take those basic ingredients, those elements, and chemically lock them together? Well, then you get a compound. And our star player, water, is the perfect example. It's always two hydrogen atoms bonded to one oxygen atom. That H2O formula isn't just a suggestion, it's a fixed chemical recipe. Now, this brings us to a really, really important question. We know water is a compound because its atoms are chemically bonded. But what if you just throw a bunch of things together in a bowl without any chemical bonds forming? Well, that is what we call a mixture, and knowing the difference is key. And this chart here just lays it all out for us. With a compound like water, the elements are chemically locked together. And here's the wild part. They completely lose their original properties. Hydrogen and oxygen are both gases, but when they form water, they become a liquid. On the other hand, in a mixture like a salad or the air, everything is just physically combined. The components keep their properties. A tomato is still a tomato in a salad. And the ratio can change, right? You can always add more carrots to your salad, but you can't just add more oxygen to H2O and still call it water. Okay, let's move on from salads and talk about probably the most important mixture for life on Earth, the air we're all breathing right now. It feels like one single thing, doesn't it? Just air. But nope. It is a classic example of a mixture. Just take a look at these numbers. The air is mostly the element nitrogen, about 78%. Then you've got the element oxygen at around 21%. The critical thing to remember is that these gases aren't chemically bonded together to create some new air molecule. They're just physically mixed, all hanging out and sharing the same space. That is the definition of a mixture. So why do we even care about these labels? Well, it matters a lot. As this quote gets at, once scientists understand that air is a mixture, they can start to study its individual parts. That's how we're able to track pollution, understand how our bodies use oxygen to live, and even model huge things like climate science. It's incredibly practical stuff. So, let's bring all these ideas back together. We've looked at the different states of matter and the different ways it can be composed. What you really have now is a kind of mental toolkit for classifying almost anything you run into in the real world. And here's that toolkit. It really just comes down to asking two simple questions. First, how does it exist? Is it a solid, a liquid, a gas, or even plasma? And second, okay, but what is it made of? Is it a pure element, a chemically bonded compound, or just a physical mixture of different things? And here's the real takeaway. These aren't just vocabulary words to memorize for a test. This whole system of classification is the foundation that allows scientists, and now you, to describe the world with incredible precision and even predict how different materials are going to behave. It works for everything from a simple glass of water to a distant burning star. And that brings us to the end. But I want to leave you with a little challenge. Just look around your home. Think about your morning coffee, the milk in your fridge, even the soap you use. Using your new toolkit, how would you start to classify them? Give it a try. You might be surprised by how much complex chemistry is happening all around you every single day.